What are your experiences at EuRoC?
None of us personally have been, so we're all quite excited to go. The team has been twice. First year, I believe 6 members. They had a successful launch, successfully recovered the rocket as well. And then the second year was 2022. Rocket was a sort of evolution of the previous year's rocket. Sadly, didn't make it off the launch pad. There was some sort of manufacturing defect with the solid rocket motor, which was out of our hands. It essentially exploded, which destroyed most of the rear half of the rocket. So unfortunately, not only did we not get to fly, not get any data, but we also lost the rocket. That was obviously a bit disappointing, but we're hoping to come back stronger this year. We've had a year away from EuRoC, so yeah, it should be good. I guess expected difficulties, because there's not a lot of experience going to EuRoC in the team. Yeah, we've never written the documentation for EuRoC, so that'll be a lot of effort, but hopefully it will pay off. We've got support from some ex-team members who said they're willing to give us advice for that. I mean, the other challenges are, as every team faces, various issues with just making sure everything works on the day. Some of the modeling we've been doing has been indicating that the temperature on the day might have an effect on our final altitude. So yeah, we'll see how that goes. Obviously, you can't predict that.
The way that we have designed our vehicle, we're also liable to take part in final design reviews in quite a few of our subsystems. So that's also something that the team doesn't have any experience with really. So we're quite keen to make sure we do a good job at those final design reviews to make sure that the people at EuRoC are also satisfied that we're conducting everything safely and properly.
Yeah, it's an ambitious project. So we're going to have to prove to EuRoC obviously that the engine works and is safe, that we've tested our fuel tanks thoroughly enough. We've got an Airbrake system, so I think EuRoC requires some extra demonstration of that working. There's a number of other areas on the rocket that will need a lot of testing and validation. So that I think will be the biggest challenge. I think we'll all be quite happy if we get to the launch pad, and doubly happy if it makes it off the launch pad. So we're hoping to get to EuRoC this year, get as much experience as we can, come back even stronger next year and the years after.
What are your goals for this year's EuRoC?
Get to 9,000 meters. That's the category we are entering or planning to enter. So we get to 9,000 meters, that would be great. A smooth flight is really our main goal. Getting to 9,000 meters would be a bonus, and if we can recover the rocket safely, even better.
It is with how much new work that has gone into the vehicle. It's been a tremendous effort from everyone involved. So just getting to the competition and getting off the pad would already be a huge accomplishment, and then anything kind of past that is just a great bonus.
Obviously, we're going to win, but it might not happen.
No, but also we're very ambitious this year.
Yeah, it's a much more ambitious project. We're going to put a lot of effort into our sort of initial application and documentation, and all the different reviews. Just to really prove to EuRoC that we know what we're doing.
Do you want to join other competitions apart from EuRoC and Race for Space?
Yeah, I mean, so obviously we've been to Spaceport America Cup in the past, and I'm sure we'd love to go again. That's more of a budget issue than a sort of wanting to go issue. We would really like to see a competition in the UK, because obviously only having one opportunity to launch, i.e. at EuRoC, isn't ideal. It's not a lot of testing time. So we know of other teams that have launched in the UK. There are a couple of spaceports. There's one up in Scotland, one in Cornwall, but I'm not sure they do vertical launch. But there are a few spaceports around, and we would like to see maybe teams could get together.
Is there one in the Midlands as well?
Unfortunately, the main UK competitions like MAC, they don't really. Our vehicle would certainly be too powerful for that kind of competition. So it would be great to see something that kind of a competition that can deal with the same kind of classes vehicles as EuRoC in the UK, for sure.
Yeah, and I think there's a market for it. As we said at the beginning, there's a lot of teams in the UK building rockets of a similar size to ours. I think an opportunity for us all to launch against each other would be really good. But we'll see. I'm sure one will happen in the future. There's been talk about it. I know when COVID happened, there was some chat amongst the UK teams about getting a competition going. It never happened, but might happen one day.
How do you see rocketry evolving in the future?
We hope to see that a move away from that classic aerospace company mindset. So the very slow moving, very tried and true methods, which are very safe, but the existence of companies like Rocket Lab or SpaceX show that you can iterate a lot faster. We kind of hope to be part of that. As you said, because of how budget constrained we are, we're using a lot of slightly more novel manufacturing techniques that are a bit cheaper, like 3D printing and things like that. So we hope that kind of it will move more in that direction as more and more teams and companies want to get involved in it. The application of those kinds of manufacturing techniques are a bit more widely adopted in the industry.
Yeah, I mean, 3D printing is the big one. Obviously, there's big companies in the industry doing it, like Relative to Space, smaller teams. We haven't done any metal 3D printing yet, but it's definitely something that's in our sort of scope for the future. But there are other teams in the UK and in Europe that are doing it. I'm pretty sure the Imperial rocket team has got some 3D printed parts on their rocket, which is cool, as well as Sheffield. Yeah. So that is, I think, the pretty clear direction that the industry is moving.
But also, I guess, developing hybrid propulsion.
Lots of teams now are, I mean, at Race to Space, it seems to see more than half of the entrants are hybrid vehicles, some biprops. So I can imagine that competitions like student design motors will also become more normal over time.
And I mean, I guess the other thing is more environmentally friendly manufacturing methods. Obviously, we've been looking at the fuel that we mentioned earlier, so beeswax, sort of as a replacement for paraffin wax. It would be nice to see teams sort of and companies moving towards more sustainable materials, more sustainable composites and manufacturing methods. I think there's a lot of research happening in that area.
How much do you build your rocket yourself, and how much do you outsource to sponsors?
We're manufacturing either by the university workshop or us ourselves. Almost every we're manufacturing the fuselage, we manufacture the airbrakes ourselves. All of our bulkheads were machined in house. The only thing that isn't really going to be manufactured by us is some laser cut metal parts, I believe.
The Aerospike as well.
And the Aerospike will also not be manufactured by us. But we wanted to get our fuselage laid up. So we're doing lots of it, which is great because it means there's some very hands-on things that lots of people can get involved with. So when we go to lay our fuselage, it's more than 2 meters long. That will have lots of people involved in that.
Quite fortunate that the university technicians are willing to spend their time manufacturing stuff for us for free. So we buy the materials, give it to them along with the drawings, and they manufacture it for us. So that's really useful for the sort of metal machined parts. And they're obviously very experienced, and it's done to a very high quality. And then we've got our own workshop that we do a lot of the work in.
The interacting with the machinists, it's one of those things that the members really get to learn a lot from. A lot of the time, the machinists know far more than any engineer does about what's possible to manufacture and how you can make your designs better for manufacture. So,
and they'll just tell you if it's not.
And they'll tell you if it's not done properly. So it's a really good opportunity for a lot of the members to learn how to design things well to manufacture.
Another thing actually that we've got to mention, the nose cone.
Oh no, I can't.
So this is our nose cone. It was bought from an American company. It was bought from Public Missiles a couple of years ago. That's the nose cone we're using, and that's it's fiberglass as well. But we didn't lay it up ourselves.
But also for manufacturing, we want to get more first and second years involved so that they can have a hands-on experience and then carry on with the knowledge they will have learned for the future years of the rocket, because we're graduating this year.
Want to try give them some skills that they can use in future years for the rocket. We're also in the avionics. We're doing most of that ourselves. Apart from we've got supplier helping us with some sensor systems, but otherwise everyone's doing we've got a team doing the programming and the component selection and design themselves.
What software do you use to design the engine and the rocket?
All of the analysis is done in MATLAB, so that's things like the engine design. Our engine lead has built like a full simulation systems engineering model in MATLAB, and then sort of various other pieces of software. So there's some analysis being done in ANSYS, so that's structural analysis on things like the fuel tanks, and CFD on the fins and the nose cone and inside the engine, and also thermodynamics analysis inside the engine. That's all in ANSYS. And then the main CAD design and some other structural analysis work is done in Autodesk Inventor. So that's sort of from a design point of view, MATLAB, ANSYS, and Inventor.
I think we also have someone working on Nastran structures.
Yes.
Yeah, Autodesk Nastran, Inventor Nastran as well. In terms of other software, there is a guy on the team developing a sort of flight simulation, flight dynamics model in Fortran. Hopefully, probably won't be done in time for EuRoC this year, but in future years, the team can use that as a development tool. We've had similar softwares designed in MATLAB in previous years. EuRoC requires the use of Rocketry, so we'll use that as well for flight dynamics planning and simulation.
What electronics do you use in your rockets?
We're not doing a custom PCB this year, although that was done in 2021 and 2 rockets. So it's probably something the team will come to in the future. We're not doing it this year just due to time constraints mainly. Sensor package is being developed in partnership with a company called 3D Photonics. They're going to be helping us to design some of the sensor systems that we can integrate into our avionics. And then the main system is just so
the main system runs off Raspberry Pi Picos, and I think a handful of them will be used. So one will be dedicated to the Airbrakes, one is dedicated to the engine throttle control, and then one is dedicated to the recovery system. Alongside that, we have the CATS Vega, which EuRoC uses for their apogee measurement for the competition. But we'll also be using that as our redundant flight computer to activate the recovery system should it be needed.
What do you want to use for your launch rail?
We'll just be using the EuRoC supplied launch rail. The rocket will have some rail lugs mounted to the side on hard points that will slide along the rail. So not doing anything fancy there. Other ground support equipment, we'll have a telemetry station, uplink and downlink to the rocket, which is still a work in progress. And then, various sort of filling systems. Obviously, EuRoC requires that we can vent the rocket remotely, so that's another system that we'll have.
We will have on-rail charging.
Yeah.
Although I don't know how that's implemented, but yeah, that's something we will do, so we don't have to worry too much about the batteries running out whilst we're on the rail.
What will you use for your recovery system?
The recovery system is the subject of my final dissertation. We're going to go for it's going to be a completely mechanical deployment system. We'll be using 2 discrete parachutes rather than a reefed system, neither of which will be parafoils, unfortunately. Just conventional parachutes, just to simplify the design slightly. We'll be using aero staging of the parachutes rather than, say, like a mortar system.
Yeah, the team, we researched using a controlled parafoil actually last year for payload recovery. We're not using it because this year we don't have a deployable payload, but it might be something we look at in the future.
Mm-hmm.
Yeah, otherwise I think it's a fairly standard parachute system, but it's different from our previous design. The previous design used a press gas mortar system, which we're not using this time around.